Okay, let's start with the webinar Supervisor Revisited. It has been a long time since I presented a webinar in Supervisor, so it was due this webinar. Look, what I'm planning to do during the webinar is I'm gonna do a little bit of introduction to Datamine software and the solutions that we have, in case you are not familiar with Datamine. Then I'm gonna give you, it's a short introduction to the outlook for Supervisor and some of the new features and improvement. And then I will show you some of the tools that we have in Supervisor. It's not new, but it's something that I believe is like a little tricks that makes Supervisor really good and that probably are not used as often as I would like to see them used in practice. Okay. So look, to start with Datamine, as you know, Datamine is one partner for every solution. Datamine is the global leader in mining software. We provide cutting-edge technology, and we are trusted by the industry with more than 6,000 customers around the world. And of course, we have a comprehensive software suite that covers the entire mining chain. You can see that we have solutions for exploration, geology, where StudioRM, iSatis, Supervisor, and iSatis.py are. And we have solutions for planning, production, labs, and sustainability. Of course, some of the clients that we have, we would like to show this. We got the segment leaders like Newmont, and we got First Quantum, SQM, of course, the big players like Rio Tinto, BHP, Vale, and Anglo America, and consultant. All these segment leaders, explorers, and service providers using our solutions. We have worldwide expertise and with local support. You can see the slide is showing you all the locations where Datamine has offices and provide support. In Datamine, we also offer training courses. You can go to the web page and see the training courses that we offer. The Supervisor Fundamental is just one of the training courses, but we also offer courses on sampling theory and QA/QC and advanced topics like conditional simulation and resource estimation and nonlinear resource estimation. And of course, the training is available as an online, in-house, or online and in-person courses. So if you want to have more information about the training courses, all the information is in the Datamine webpage. What we have coming up is the Geology Symposium in August. So if you are in Perth, you are welcome to attend this Geology Symposium. We do this every year. It's great opportunity to see what people are doing with the software, with the solutions that we have, and share with peers. You can use the QR code to register now, and it's free. It's a free event. Any questions? I'm pretty sure Beth can answer all the questions regarding the Geology Symposium, but you will also find all the information on the Datamine webpage. Look, let me start now with the outlook for Supervisor. You probably, if you are a Supervisor user, you probably got the news, it was probably around May, that now the development of Supervisor is being done by GeoVariance, or is looked after by geovariances based in France. The idea of the exchange is that to have a full development team to support the development of supervisors. So now you will see, I'm going to mention that later on, we have a team dedicated to the user experience or the interface. We have the QA engineer for testing, developers. This team also develops iStatis Neo. And of course, the team works closely with the Studio RM team. And that enables seamless collaboration between Supervisor, iStatis Neo, and Studio RM. The support is still managed at the regional level. So let's say if you are in Australia, the support is managed here in Australia. Let me introduce to you the development team. Ophelie is the product manager for Supervisor and iStatis Neo. Benjamin is the development manager. Pauline as the test engineer, and Elodie is the UX designer. And we have 3 full dedicated software developers for Supervisor. Now, we haven't done a lot of improvement in Supervisor. We moved from version 8 to version 9. But I want to mention some of the features that we recently include in version 9.1. Okay? So, but before I do that, let me remind you that version 9.1 was released in May in 2025. And if you are familiar with Supervisor, you may remember that every time we install Supervisor, there is a program called DirectX that is installed on top of Supervisor. Now the installer brings in the DirectX, so we don't need to install that on top of Supervisor. Something that you need to be really careful when using version 9.1 is that there is no backward compatibility. So the suggestion, as mentioned on the slide, is that you can open your version 9 project, but save the version 9.1 project with a different name. So you can retain your old project and the new project just in case. There has been some minor improvement. For instance, if you are a Leapfrog user, before we have a limit, or Leapfrog had a limit of 2 structures. For the variography, this is no longer the case. So we remove that 2 structure limitation in Supervisor. Now you can model up to 4 structures in Supervisor and export your variogram model. We also now have an option to increase the font size, so you can see the parameters defining the variogram structures like the seal and the ranges. And when using the box plot, now there is an option where we can select all the box plot with a single click. There is another facility that was introduced in 9.1. And the idea here is to rotate the data to match the local coordinates of the block model. I was recently testing this and I noticed it's not general enough. So I decided to put this on the webinar and show you meantime what you can do. So basically the idea is that you have a rotated block model in Datamine format. You import the data and then you rig the block model. So here, what the supervisor is doing is reading the rotation of this Datamine block model. At the moment, the rotation is limited to setting the rotation axis number 2 and rotation axis number 3 to 2 and 1. Yeah. So basically, if you use this rotation, supervisor will read automatically all the parameters and rotate the data. This way, we can run the model validation because we have the data and the block model in the same local coordinates, okay? So this is the workaround. The development team is already aware of this limitation, and we are working to put general rotations here to bring the rotated drill hole data. Okay, so what is coming in Supervisor? You will see the development team will maintain the pace. So we are expecting to have 3 major releases per year. Version 9.2 is the next one. And you will see that in version 9.2, we will bring the highlight between graphics. This is something that is very common in iSatis Neo for the iSatis Neo users, and we will improve the user experience with demo projects and dark mode in Supervisor. We will have the ability to read the DMX files that Datamine introduced recently and connection to MineTrust. It will be an upgrade from NEC 6 to NEC 9. We have received information that some companies are not allowing to install NEC 6. It seems that there are some vulnerability issues. That's the reason we are in upgrading Supervisor to use NEC 9 in 9.2, in the version 9.2. Something that we got a number of requests is improvement to the 3D viewer is coming. I understand the development team will look after this. Something that we also want to improve is the auto-fitting process in Supervisor. If you have used the auto-fitting, you will see that in some cases is fitting very long ranges for the variogram. Or is increasing the nuggets. So we will see an improvement on this auto-fitting process. Okay, so now I want to show you, as I mentioned during the introduction, I want to show you like a few things in Supervisor that are handy when we are doing the EDA or when working with Supervisor. Is nothing new. But I hope you like these little tricks. You will see. So let me start with something. It's a parameter that is really important in Supervisor, and is what we call the granularity. The granularity is a key parameter when doing variography in Supervisor. Remember that when you use Supervisor, rather than computing a single experimental variogram, Supervisor generates a set of variogram using lag intervals defined by the granularity value. And this approach enables more robust assessment of the goodness of fitting. I'm going to show you exactly what I mean with the granularity when I show you Supervisor, but this is an important parameter. The next one with variography is that is traditional, you know, when we compute the variograms in Supervisor, that we use 3 variogram fans, and after inserting the 3 variogram fans, we have the continuity models, and then we go and model the variograms in the directions that we selected in the variogram fans. Look, this is the standard process in Supervisor. But in practice, if you know already, right, your rotations, or if, let's say, you are working on one domain with a number of attributes and all of them share exactly the same direction, you don't have to insert the variograms again and insert the variogram fans again and compute all that. This may be time consuming if the data is really large. So instead of that, we can insert the continuity models straight from the data using the rotations. You can see that the rotations I have here are exactly the rotations that I have in here. And then we can avoid computing the variogram funds and go straight to the variogram models. These are like two key characteristics of the variography in Supervisor. And probably the latest one or the later one I want to show you is something that is not very used in practice, but it could be really handy. And is this ability to use lag intervals in Supervisor, right? In Supervisor, we can have up to 3 lag intervals. And the idea here is that we can improve the variogram calculation when we have different drilling densities. So you can see here, I'm about to show you this in Supervisor, but you can see here that for short distances, I'm using a very small lag, right? So taking advantage of the drill spacing that is really tight, the part that is really tight. And for long distances, I'm using then a larger lag. So just let me switch to Supervisor. And I can quickly show you this. So in here is what I mentioned before. So I go, for instance, data in 3D, and I go my variograms, right? So you can see the 3 variogram funds, and then you can see the continuity model. Look, what I mentioned about the granularity is important because, for instance, I can come to this variogram here and I can move the variogram, so I can change the experimental variogram. So the reason I can do this is because all those experimental variograms were already computed. And when I move the lag bar here, what I'm doing is just displaying the variogram. So that's why I was really keen to show you the impact of this granularity option. For instance, suppose that you have a really large data set, but you have, let's say, more or less the drill spacing is 20 by 20. There is no reason to set the granularity to 5, for instance. Okay? We know more or less the drill spacing, and we can save a lot of time just setting this value properly. Okay? So remember this, when we compute the experimental variograms in Supervisor, Supervisor doesn't compute only one variogram. We compute a large number of variograms so we can run this and see how the model fits the different experimental variograms. And in here is what I mentioned before, so I can have exactly the same variograms, right? If I use the continuity models. So to insert the continuity models, you just go to the data, you right click, and then you say continuity models. Once you do that, you will have that option here, and then you can go to models, and in here is where you set components. Here we go. Okay, and in here is where you can set your rotation. So this will save you a lot of time. For instance, you know, when you run the conditional simulation in Supervisor, we don't have a specific tool to run the variogram swarm. I mean, to compare all the variograms of the different simulations. But we can use this tool in a selected number of simulations using the rotations that we use for the variogram and see how the variogram compares with the simulation. Okay, so the variogram, the lag, what I did is I used this small data set, okay? So you can see here that I got the data, and instead of using the variogram funds, I inserted the continuity models. I know exactly what the directions are. And then you can now, for instance, go to your variogram, right? And you can see that I'm using 2 different lags. So you can see that if I change my lag bar here, I'm just changing only the points that are close to the origin or the small distances. And if I change the lag in here, I'm just changing that part of the variogram for long distances. So all that information is right here. Is very handy to compute the variograms when you have different drill densities. Okay, so just let me get back now to my presentation. Okay, and I'm going to show you something about the indicator kriging or multiple indicator kriging that I don't know if it's being used a lot, but it's very handy. I do believe it is really good. So the idea here is that, look, in Supervisor, we don't run MIK or multiple indicator kriging, but the idea is to help with the variography process. You know that in MIK, we need to do we need to compute a lot of variogram. So the way to compute the indicators variogram in Supervisor is exactly the same variography process, but we need to insert that under the log probability plot. And when you insert the different threshold of the different cutoff, you can have information about the stacks. You know, for instance, in MIK, it's really important, for instance, that you define the stacks within the thresholds or above the threshold. So every time you change one of those options here, right, you're just saying report the stacks that are above the threshold or report the stacks between two thresholds. And we can see exactly what is the mean of the data inside the two thresholds to say the MIK estimation. And of course, we have in Supervisor a really good functionality that is copy and paste, and we can use that to save time. Let me see if I'm gonna mention something different, but just let me get back to Supervisor to show you how to do this. For instance, I can, if I have my log probability plot, for instance, okay? So I said that for MIK, we run the variography here. So basically, we need to add some thresholds. In this case, I'm going to add 10 of them. So these are the different thresholds. We can always go and change these values. So we can say instead of the 5%, instead of the 10%, we can define the 5% threshold. So you can see is here, or we can put this back to, let's say, 15. Yeah, so you can customize, or you can define your own threshold here. What I usually do with MIK, I start with the median cutoff. So I can go here and say, look, add my horizontal continuity fan, then I can add the cross strike and the deep plane. That's the way I like to do it. I also insert the continuity models, and then I can start analyzing the continuity. So you can see here, we got a really nice trend going north. So I'm gonna leave it there. I got now this trend. This is a really nice data set. It's real gold data, but it's a really cool data set. So I go and now update my deep plane. Then I have my variography. Okay. So when I mentioned the copy paste, if you are not familiar with this, so one way I mentioned is of saving time. I can come here to see if that is my variogram, and I can come to, let's say, the 30 percentile and paste it, and then update my variography. I can go and check what are the directions, but I don't need to go through the whole process of inserting the variogram again. Okay, so just let me now get back to the presentation. Look, something that Supervisor has and is really handy as well are the templates. Basically, the templates let you save and reuse component across projects, as mentioned on the presentation. It's like as I put on the presentation, it's like a way of copy and paste. But basically, what it is we got the data, we got the domains, and instead of repeating exactly the same all over again, we can save, let's say, the variograms in normal scores. We can save the clustering, and we can save KNA. And we use that in play, so we don't have to insert all these components all the time. You can save the template. It's not totally flexible, so it's not like a coding, but you need to remember that when using templates, what you need to have is exactly the same domains and the same assays. So we can insert the templates. Let me quickly show you how to do this. I got another project here. Look, this is exactly the same data set I was showing you before. It's the data in 3D, as I mentioned, is 3D data set. Let me color code this by the percentage. And what I'm gonna do is give you an example. Suppose that we got the same assay, the same domain, and now I want to repeat, or I want to insert a number of components in Supervisor. So I can go here, and then I can add my template, and you will see I already create a template for EDA. So if I click here, you can see that what the template is doing is saying, okay, you got a decluster component, and you got some continuity models in this direction, and after inserting this variogram model, you have to do some KNA. So I can go here and easily update, yep, all these components, and get my variogram, get my decluster, and get my KNA done. So it can be done on a step-by-step basis, but if you already have the same data, the same domains and the same assays, you can use a template to save time. Okay. Look, the last part I would like to show you is something that it has been in Supervisor for a long time, is what we call the probability maps, or the probability cutoff component in Supervisor. This is related to conditional simulation in Supervisor. Look, the idea of the probability component here is that we run a number of simulations. We reblock that, and what happened now is that for each block, you have a number of simulations. Let's say that you have 10, okay? So the idea now is to apply a cutoff and say, look, what are the proportion of simulated values about the cutoff in this block? And we use that proportion to color code the block. So you can see here, for instance, right, the probability of being about 100 is 1. Yep. So and when we start increasing the cutoff for 150, 200, all this area is still there. So we can always export this as a, let's say, Datamine block model or CSV, and we have all the information. So we can use the probability maps, but we can also create the local CDF from the probability maps. For instance, if you export this as a CSV, yeah, you can see that what the probability map is giving you is a series of numbers. So this one here is the probability of being about the cutoff of 100 is 0.9. This is just one block, okay? This is the probability of being about 50, 150 is 0.8, and so on. So if we want to get the CDF, what we have to do is just take 1 minus this number. So 1 minus this number is the probability of being below 100, which is the CDF for that particular block. So with a quick post-processing result here, we can transform this probability about cutoff to a CDF. And then we get the CDF for every single block. For instance, I wanted to show you this because if you are familiar with MAK, we are always looking for a CDF, right? A block support. You need to run kriging a number of times, you need to set the variograms, and you need to do chain of support. With conditional simulation and using Supervisor, you can have straight your CDF at block support. And I guess that's a little bit more, which is this one is really good. You probably have heard of drill hole spacing analysis. There has been a lot of applications now in drill hole spacing. In Supervisor, we have a component that we call grade control drill hole spacing analysis. Is shown right here. Look, the component is not specifically designed to run this 90-15 classification rule. I'm going to give you more information about that, but it can be used for that purpose. The idea of this 90-15 classification rule is that we can relate drill hole spacing, production period, and some sort of classification. And the classification is assigned on the ability to predict the grade on production parcels within 50% relative precision at 90% confidence level. This is the criteria that was put together by Harry Parkers and other practitioners. But look, how can we use this grade control drill hole spacing analysis? Basically, you can see that what the criteria to assign the confidence interval is we need a number, and this number is the 90% confidence limit based on the Gaussian distribution, right? This one here is the square root of the kriging variance, right? Using a variogram of CIL with CIL equal to 1. And this one here is the coefficient of variation of the data. So basically what we have to do is we need to take a production parcel, a production period, let's say 1 year. We define a big block that is equivalent to that production period. We use drill hole spacing, different drill hole spacing, and we compute this value. We compute the kriging variance. And we use this equation. And we are looking for drill hole spacing that report this value less than 15. So when you look at the component, you can see that in Supervisor, we can export this result, right? So we can export the square root of the kriging variance for that production period for different drill spacing. So basically, we need is to multiply the square root by the coefficient of variation with this number, and we get the relative confidence, right? So you can see that in this particular case, for drill holes on a 50 by 50, we are below the 15%. 100 by 100, we're getting there. Probably for 100 and 150 or 150 now, we are above this threshold. So as I say, the component is not specifically designed to use the criteria, but using a big block, we can compute the kriging variance with different drill spacing, and we can do this manually outside of Supervisor to get the graph. And I guess that's it. So, okay, I was not too bad. I was expecting probably 20 minutes, but it took me around half an hour. So look, thank you for attending the webinar on Supervisor. I hope you like the webinar and you see the value of what I show you. Look, I'm open to answer questions now, Beck. If we have any questions on the chat, please let me know.